Good job.
How we doing with outcomes, yeah? Ooh, sauciness, I love it. We got averages. We've done our census. So I just handed you guys a whole bunch of stuff back. Just page through it. Make sure things look legit. If they don't look legit, grab me at break. We'll figure out the non-legitness. Figure out what's going on. So what I did this morning or last night, I forget what it was. I sat down and ran these numbers too. I had the dice in front of me, and I created the averages and the standard deviations based on the outcomes. So I want to make sure that I have the same numbers you guys do. So I know that you all have different colored dice. Here's the blue one. I know I matched these guys up here that had the blue dice. I'm not sure who else had blue dice in the room, but I got an average of about 8.17 with a standard deviation of 2.65. Is that agreement with the other blue folks? This is you guys. Who else has blue dice? Because you're going to get to know the folks that have the same colored dice as you, because you're going to have to beat them later. And 2 other groups have blue dice, yes? Okay, you guys, is matching up with what you guys got? Or you're still working? You're still crunching. Okay. Hold that thought. Who else has blue? There should be 3 sets. Oh, you guys too. Matching? Ish? Oh, you're still working on it. I'm sorry, guys. I got a little late. So, the idea of this one was, it looks different than that. That's the point. It's supposed to look different than a fair pair of dice. I loaded the dice to make the higher numbers occur more frequently than the lower ones. So I'm describing this as a skewed distribution, which I think is fair. Okay? Yellow. That's you guys. How's that look compared to what you guys got? Let me. It's don't worry. Don't worry if they're 1 or 2 off. If they're getting close to this distribution, I'm happy. Because you got to remember the fiction of what we're talking about doing anyway. The fiction is, I told you to go measure your population. Can you do that in reality? No! I mean, even the Census Bureau itself hasn't did it. It can't do it anymore. It can't do it anymore. So if you're having a hard time measuring your population, that's probably understandable. So are we close? You guys are getting a crazy left distribution?
Yeah, that's right, but how come my numbers on the bottom don't match up?
These guys here?
Yeah, they should be the same.
They should be if we have exactly the same distribution. Do you have exactly what I have here?
Yeah.
Let's check the math at break. Let's take a look. I ran this through Excel. So
the TIs though, like different models, they'll compute a little bit differently.
Oh God,
so you'll have like that percentages.
Jesus. So 2 plus 2 isn't always 4 with
Yeah, it's always, yeah, it might be 4.17.
It's making me scared. It's a little bit scared. So anyway, the average is lower, as you can see, because the majority of the curve is to the left. Whereas a fair dice average is up at 7. This one comes down lower than 2.2 standard deviation. Keep that on the back burner for right now. Here's what the green dice look like.
Never mind, I didn't.
Yes. Here's what your green dice look like. It's definitely a symmetric distribution, which is fun, but it's not symmetric like the original fair dice distribution. It's got the same average. It's got the same average. What I was actually trying to do with this pair of dice was, I was trying to make a distribution that was shaped like a U. So I wanted a whole bunch of 2s and a whole bunch of 12s. Why couldn't I? Why couldn't I? I tried for a while, then I realized it was an impossible task, so I stopped trying. But why can't I get a distribution that's shaped like a U? Which is what I really wanted. I wanted this crazy bimodal U-shaped Weibull distribution.
Well, they're adding together, so
The problem is, if I have a whole bunch of 2s, that means I've got 1s and 1s on dice. And if I have a whole bunch of 12s, I've got 6s and 6s on dice. And if I have a whole bunch of 1s and a whole bunch of 6s, I have to have 7s at some point, and probably a lot of them, which is when I ended up accepting this as a second place. And it's fun because it has like flipping the bird kind of mentality to it. That was the only one of the 5 pairs of dice I handed out where both the dice were exactly the same. You may have noticed that. Who has green? You guys have green? Both of your dice were identical, where the other folks had different dice on both of theirs. Just kind of fun. The orange was a fun one. Ooh. I like this one just because it had so many gaps in it. You guys over here remember orange because you didn't have any 2s and 3s, started at 4 with 10. And I love the average of this one because the average is nowhere near where the spikes are. The average is at 7.
No 1s, no 5s.
Which is the same as that green distribution. But look at how tight the standard deviation is comparatively. It's like 1 less. It's 30% of the standard deviation of the previous one. Because there's no extremes here, no extremes here. They're all clustered here. And then you have this little goofy secondary hump over here. So I like that one just because it's bimodal and kind of weird. And then over here, this is the only one, if you had the red ones, these looked like a bell curve, which we were talking about all last week. It was the only one that looked. Who had red? You guys had red, red, and red, and it's the only one that had a bell-shaped curve in the distribution itself. High average of 9.2 with a very, very small standard deviation comparatively, and you can see why. It's clustered in really closely together. Clustered in really closely together. Now, if in case you didn't get exactly what I got up here, I'm not that worried about it. I'm not that worried. So if your yellow was off a little tiny bit, Lauren, I can live with that. And the reason is, if I gave you the impossible task of going out and measuring your population, it would be impossible and you couldn't do it. So what do you do instead?
Isn't it possible with dice though?
Well, yes, with this pair of dice, of course. With dice, with coins, with cards.
Then there won't be error.
Well, in the case of dice, yes. But remember what I told you, your die were symbolizing when we started. They're symbolizing, for example, the level of cholesterol reduction a certain new drug has. So sure, for a pair of dice, this is why I had you count them. And now we now have the parameters. We now have the parameters mu and sigma for all 5 of these distributions. Now, the reality is, you can't get that in most cases. You can with dice, you can with coins, you can with cards. You can do all that stuff. But you can't do it in reality with any realistic data set outside of Vegas gambling odds. So, what do?
It's a sample.
You draw samples from your population. What we're going to do is we're going to break a little bit early, and then take 5 and then come back. And then I'm going to have you guys actually roll these dice. Because even though you don't know that mu is going to be 9.2 in this distribution, it would be nice to be able to find out about what mu equals through a sample, yes? So for example, even if you know you can't figure out the exact level of cholesterol reduction a certain drug will do, it would be really nice to estimate what that level is to see if your drug's actually working. It would be nice to know that Ritalin actually does control symptoms of ADHD. I mean, this is one of the most amazing things I've ever heard about. Ritalin, which is a stimulant, controls the effects of ADHD, which is essentially overstimulation. Amazing to me. How do you discover stuff like that? You can't go out there and measure every single ADHD kid and their levels of engagement or overactivity. You'll look for 10 weeks up here. But a study was done, and the average showed in the study that Ritalin was having an effect. You can't measure every single kid, but you can measure a chunk of them, take the average and say, it looks like on average this is doing something. It looks like on average my drug is lowering cholesterol. It looks like on average this rubber lasts long on tire than this rubber does. These are safer for winter road conditions. You can't measure every single tire, every single kid, every single blood vessel, but you can draw a sample. And that's what I want to do once we come back from our 5. So take 5. If you have questions on grades, let's get those answered right now. And we'll come back and we'll start rolling some dice and do some sample. Yes? Yes. All right, let's turn this off.